Awesome. Great. Well, welcome everybody to the November Java user group meeting. For those of you that are new or have not been at one of our meetings in the past, we've been doing this online thing. I think since end of last year, beginning of this year, or something like that. So I see some old faces. I see some new faces. So hello to everybody that's an old face, and for that matter, hello to everybody that's a new face also, and an additional welcome. So real quick, the Seattle Java user group is our local JUG here in the Puget Sound, Seattle area. And today we have a talk on observability, talking about going beyond the typical sort of 3 parts of observability, specifically with Spring as an example from Jonatan, who's actually one of our co-organizers here. So I'm just going to jump right into this little slide deck here. Let me see if I can do this. All right. So for those of you that are new to the group, what is the Java user group? Well, the Java user group is dedicated to helping you, developers, specifically Java or JVM-based developers, but developers in general. Mostly we like to create a vibrant community, learn more about contributing to the Java JVM ecosystem, mentoring, career opportunities, networking, and in general, having fun and building really, really cool things. Obviously, with COVID and all, we've been doing the online thing, so it hasn't quite been as much fun as it was meeting in person, but hopefully, with things turning in the right direction, I'm hoping next year we can go back to doing in-person meetings, but we'll see. So for those of you that are new to the group and here for the first time, please share the love, come back. We have all kinds of exciting sessions all the time, and feel free to invite people that you know at your company or other groups that might find value in our sessions. And really the whole idea is to create a community around this. And, frankly, the Java user group community at Seattle has been going pretty strong from like the mid 90s, and it still continues to go strong. Despite Java being like 2 decades old at this point, and lots of other interesting languages with features and what have you. But if you're interested in volunteering, if you want to help out, you want to speak, please just reach out to us anytime. leadership@cjug.org. And these email addresses should be on the cjug.org website also. Quick little note on code of conduct, just making sure that everybody, plays nice with everybody else. We believe in being inclusive, being curious, asking questions, avoiding assumptions, growing trust, empathy, friendship, just being nice to each other and being polite and having positive intent. I know sometimes online it can be a little challenging trying to, it's a lot easier to misconstrue what people are trying to say, but let's be civil. Let's see some stats. We got a little over 2,000 members now, from the looks of it, across a bunch of different social media platforms. And as I mentioned, we're doing virtual meetings this year and hopefully in person next year. Upcoming events, we've got speakers or talks lined up through December and January at this point in time. I can't remember off the top of my head what those talks are. But again, if you're interested or anybody you know who's interested, please reach out. Our audience loves hearing about open source stuff, about tools and technologies for developers and cloud related things. So logistics, everything's at your home there. So obviously, facilities and all right there. And then I also want to take a quick moment to thank our sponsor, that is JFrog. They've been kind enough to provide us with some funds this year, which is kind of nice because that's helped pay for a few things that typically we've kind of paid for ourselves in the past. And then, today we've got Jonatan, who, as I mentioned, is one of our co-organizers, is on the Spring engineering team. He's a speaker, an author, and a certified Dragon trainer. And then his website's Developers. Interesting, I actually didn't know about that. But with that, I think I'll hand it off to Jonatan. So all yours.
Thank you. Let me share my screen. Can you see it? And I hope this also stopped Nimret's sharing. Cool.
I can see it.
Yep, you're good.
Give me one more second because I lost the video. Here we go. Okay, so hi, I'm Jonathan. I am a member of the Spring engineering team, and I usually work on Micrometer, Spring Cloud Sleuth. I'm a little bit anxious right now because like there is somebody here in the participants who was the original author of Spring Cloud Sleuth. Hi, Spencer. And I also work on a new initiative called Spring Observability. Hopefully we'll see that a year from now or so. So if you have heard about observability, could you please give me some feedback, like a +1 in the chat, or like a thumbs up in the as a reaction? Like that's one. I am 100% sure there are more people. Yep. Okay, we have a few. Cool. That's great. Let me put this into full screen in the meantime. Okay, so the agenda for today is I would like to talk about a little bit about observability. What is it? Why do we need it? What are the three pillars, or the so-called three pillars that you can hear like quite frequently, namely logging metrics and distributed tracing. And I also want to talk a little bit about some non-conventional observability. Maybe that's the most fun part, per my opinion. And also I will walk you through a demo. So as a couple of you have already heard about observability, we can continue. You all know what is it exactly. But if you look into the definition, or if you hear like people just like walking you through it, I am not 100% sure usually that it is an obvious thing that you can grasp on. So, oops. Observability is basically how well can we understand internals of something, of a system, based on the outputs that it is producing. So if it is an output that gives you meaningful information about what is going on inside of the system, maybe that makes your system more observable. Usually it's the situation. And meaningful here is key, because just adding more data doesn't necessarily mean a more observable system. And also observability is key from perspective of controllability, because it is easier or possible to control something that you can observe. And I can give you an example for this one. I studied robotics during my university years. And in these fields, there is a term called control loop. And it means like a non-terminating loop that regulates the state of some system. And we are not going to build a robot today, but let's say that we want to control the temperature of the room. And usually you have a heater and a thermostat with a thermometer in it in the room. And this is kind of your control loop. So setting the temperature tells the thermostat about the desired state, the actual room temperature, that is the current state. And also the thermostat acts like it does something to bring the current state close to the desired state by turning the heater off and on. So what if you don't have a thermometer in your room? Or what if the thermometer is outside? With the second one, this one I'm not joking, an outside thermometer is an existing thing. But without being able to observe your system, without being able to know the current temperature of the room, it can be harder or maybe impossible to control it. By the way, that's why Kubernetes controllers are called controllers. It's the same control loop idea, because Kubernetes needs to, like, in order to control something, it needs to observe as well. It needs to know the internal state of it on like some way. Why is this jumping twice? Okay, now it's okay. So, but what about software? because being able to ask arbitrary questions without knowing ahead what do you want to ask is kind of a hard case. But that's what observability is planning to do. So because our software ecosystems are usually like way more complicated than reading a thermometer, this is why we want to ask arbitrary questions about the systems, because the complexity. And we also would like to turn data points into insights so that we can troubleshoot problems quickly without having prior knowledge about the system, especially like unknown unknowns. And also observability increases operational visibility and developer productivity as a side effect. And this kind of leads us to our next slide. Does anyone know what are these images? You can just put a comment in the chat if you know any of those. If you don't, in 5 seconds, I will tell you. Relationships is kind of a, it's kind of close. These are the architecture of Amazon and Netflix and Twitter. So every point that you can see there is a service, and every edge on the graph, that is basically a service calling another one. And these are like very, very old images. As far as I know, the first one, Amazon, is from 2008. And the last one, Twitter, is 2013. I have no idea about Netflix. I did not find it. But, okay. And this is kind of like one answer, why do we need observability? Because usually we are in a cloud, and locally you can look inside of an application, you can modify it, you can debug it, you can do a lot of things what gives you visibility. And you can also usually kind of predict, you can predict what is going to happen, because you have just like locally one service or like two, a database and so on. You might not have this luxury in the cloud as of today. And you might not know where your application is running, how many instances do you have, and you can get into insane size of complexity because of this. And because of like this size and complexity, something kind of always broken. And if you think about it, cloud deployments is kind of like sending rovers to Mars. You cannot really physically like touch it or fix it anymore. After you ship it, it's gone. It's there, it will be somewhere, and you might not know where is it or what it is doing. Okay, is there anyone who knows any of these images? Just put a word or two in the chat if you like realize or if you are familiar with any of these or can identify them. If you cannot, I will tell you in a couple of seconds. Okay, so the first one, it is called Lorenz attractor. It is, yep, the second one is Dunning-Kruger. That's right. So the first one is the Lorenz attractor. It is from math. It is from chaos theory. And you can also know this as butterfly effect. And this is like a tree-shaped object, so 3D shaped object. And from one view, it can look like a butterfly. And it is also like a chaotic system. So usually this is the an image people usually show when they talk about chaos theory. And chaos theory says that a small change in one state of a known system can result in huge differences in a later state. In software, this can mean that you turn a knob here a little and services in like another region goes down. And this is basically a reference to the insane complexity we need to deal with today. The second one, as George said, it's the Dunning-Kruger effect. So the Dunning-Kruger effect, it's like a hypothetical cognitive bias. which states that people tend to overestimate their own ability. So if you look at this competence confidence graph, it begins with low competence but high confidence. This is also called Mont stupidity, I guess. So being on that peak in the beginning usually feels like the same as the beginning on the end, where you are basically an expert. And this means that we might think that we know a certain software system, but how can we make sure that we are not on that peak? Or how can we make sure that we are not fooled by unknown unknowns? And this is a reference that we cannot know everything. We need to deal with unknown unknowns every once in a while, or a lot of times. The third one, maybe that's the hardest. It is called Umwelt. The source of the image is XKCD, it's a webcomic. And this particular episode, it was called Umwelt. I believe it's not available anymore, or maybe it's broken. But the comic changed based on the browser, the resolution, or the referrer tag of yours. So what the viewer is viewing the comic on, or where they live, or where they came from, determined which comic they actually see. It was just like some JavaScript which rotated those comics based on some kind of rule set. And this was because Umwelt is the idea that because our senses are picking up different things, we actually live in very different worlds. And this is a reference that the same thing can be perceived differently by different observers. So I would like to welcome you in a world of chaos, where we need to deal with insane complexity, or maybe chaotic systems, also unknown unknowns, and everything is relative. So this is one thing why we need observability. The other thing is observability can help us a lot to improve things. And it is usually like a very good way. If you want to improve something, just start measuring it. And by the fact that you started measuring it, it by default should improve it a little at least. And I have an interesting analogy here for observability and for this image. Business people used to compare themselves to sharks. If you know Shark Tank, and there are a few shark species that needs to move to get oxygen. If those sharks stop moving, they die. And I think this sometimes true for businesses and software as well. If they stop moving, they will die. So observability is one thing that can help you to move forward, and it can like help you to improve things. And it can also open the gates or open the doors for other like, quite advanced things that you want to do. For example, chaos engineering or anomaly detection, feature flags, A/B testing, auto-tuning your applications, and also having adaptive applications too. So the three pillars, and I am not a big fan of this name, but the so-called three pillars are logging metrics and distributed tracing. And please notice that in the beginning, the definition that we gave for observability did not contain any of these. It only said how well we can understand the system based on the outputs. And it did not say that observability is in fact logging plus metrics plus distributed tracing, and if you have these, you are done. But do they give you meaningful information about what is going on inside of your system? Probably yes. Or do they make something or your system more observable? Probably yes too. So logging, metrics, and distributed tracing, just one answer for this question. How can you make things more observable? There are more answers for this one. And there are other non-conventional components I will tell you later. So right now, we don't necessarily know if like logging metrics and distributed tracing is the right answer for this question, but it is the most widespread answer as of today, at least. So let's look into these. Logging, it's usually tries to answer the question of what happened. You can emit events. They are like logs are easy to manually grab or manually read, but please don't use grep to search for logs unless it's your local box. Production, it's not fun. Metrics, on the other side, it will give you the answer of what is the context. Is it bad? That's something that you can see, for example, an event. If it is bad, how bad it is. So metrics is able to measure and combine the data. It can aggregate those data points. And because of this, it can identify trends for you. And distributed tracing usually can answer the question why something happened. Because distributed tracing is about, or mostly about, recording events with causal ordering so that you can identify the cause or the root cause across services. And let me give you an example for each of these. First, through latency. So let's say that you found an event triggered by a HTTP request in the logs, and the event said that processing this particular request took 140 milliseconds. And let's say this is in your Tomcat access logs. And that's what log is about. It will give you like a data point or an event and some like textual description with some metadata about what exactly happened for one single occurrence of an event. But metrics, it can tell you if like how bad was this? Like what is the context? What were the trends when this event happened? Is 140 milliseconds slow? Is it fast? Is it like in the Goldilocks zone? What is happening? Also, it can give you like the context of like other time spans as well. You can see the whole trend, for example, hey, like what was or how fast was this service a month ago? And I just put there like a couple of numbers here. You can plot them, but based on this data that the metrics can generate for you, you can see that 140 milliseconds in this example was quite slow, because it was in the last or the bottom 5-6%. So it is the slowest 5-6%, which is not very good. And distributed tracing can give you why this happened. Why was this like 140 milliseconds? What are the components this 100 milliseconds consist about? And you can see here in this example that service, like somebody like a client was sending a request to service A, and like transferring this request over the network took like 5 milliseconds. Then the processing time of service A was 130 milliseconds. And it was 130 because under the hood, service A like sent a request to service B, which took 10 milliseconds transferring it on the network. Service B processed it, that was 100 milliseconds, and like receiving the request, transferring it back on the network was 20, plus receiving response from service A, that was 5. So here you can kind of see that most of the time was spent on service B processing the request. And you can like do this and we can go like deeper and deeper in this kind of tree. So after this, you should be able to see why service B was slow, and this goes on and on and on. So let me give you another example through an error. So logging, it will say if you found an event that was triggered by an HTTP request in your logs and which like errored out, it will say that, hey, processing this request failed. Maybe you will see the HTTP status code, the reason phrase, or sex trace, or like whatever, but it will give you like one single data point, hey, this happened. Metrics will tell you like, was this bad? But it failed, so yeah, it was bad, but how bad? So metrics can tell you the trends again. How many errors do we have around this time? And here in the example, you can see that we had like 2 errors per second. It can be high, it can be low. before and after there was 0. So you can look at that at 5 minutes deeper if you want, like what happened there. And distributed tracing will tell you why did this happen. You can see that service A was able to like receive the request. Then the processing of service A failed because calling service B failed because of a request timeout. So this is something that you can identify the root cause with. Distributed tracing is used for this like root cause analysis in case of this error scenario. Okay, let's talk very, very quickly about logging and about the logging terminology, because most of the people are familiar with this. I just wanted to put this here in case you are not. So logging usually works with operates with 3 terms. A logger, a appender, or a layout, or sometimes it is called a pattern. And loggers are usually named objects that you can use to emit a log event. And names are usually like almost or always hierarchical. So a logger, which is usually named by the package and the class name, the fully qualified class name, that can put into a hierarchy based on the package name structure. And it also has a level. I put some levels, but like different logging libraries are working with different levelings. And it also has appenders. And appenders are used to write these log events to a destination. So you can write your logs into console, you can write into a file, you can send over a network to a socket, a database, JMS, you can send an email and ship your logs. Don't do that, but you can. As far as I know, Log4j has a email appender. And also Logger has another interesting property called additivity. And additivity is basically governs if these log events should bubble up on this hierarchy chain. So if you have like multiple appenders in this hierarchy, then with additivity you can avoid having like duplicated log shipping. Also, the last one, the layout, is basically responsible for formatting of the event. It belongs to the appender, so you can format your log event in one way in one appender and another way in another appender. Maybe you want to format your console and file log differently. I'm not sure why would you do that, but you can. Okay. There are a couple of different types of logs, and maybe this is a little bit more interesting now. What people are usually talking about when they say logging is application logs. These are the classic debugging for warn error events or the stack trace that you can see in a service. But there are a lot of other types of logs as well. For example, payload logs. Payload logs are giving you the raw request and response pairs for every request or every message. There are also GC logs, which will like give you a lot of details about what the garbage collector is doing, and this is coming from the JVM. Also, there are access logs, and these are usually coming from your HTTP server. For example, like from Tomcat, there are Tomcat access logs that you can use. And it will give you a bunch of details, and you can like configure this. And this is a very, very powerful type of log. You can tell like who and when called the service, what was the request. You will not be able to see the body, but you can see the HTTP method. You can put the headers there, the path, the query string, and so on. Also, you will see what was the response status and the processing time, also the payload size if you want. There are other types of logs as well. For example, it used to be a pattern, I don't know, like 10-ish years ago, to ship your metrics that you collected. We did not have that many metrics libraries back then, but ship your metrics that you collected into a log file. Or the tracing information that you collected as well. We did not really have like proper distributed tracing libraries back then. So if you are using Java and you want to log something, then you are usually using SLF4j. And with SLF4j, this is what you can see when you want to log something. Basically, you just need to specify the logger, which is usually specified by your class, or you can name it with a string. Then you need to call the specific method that you want, or which level do you want to emit this log event. And also, I would like to mention this last one. This is very, very important. As you can see here, it has two parameters. The message, that's the first one, the string, and the exception, which is a throwable. I have seen a lot of people putting a plus operator, which means that this will have just one parameter, the log message. In that case, you will not get the stack trace. You will only get the toString of the exception, which is basically the class of the exception and the message. Maybe that's what you want, but usually doing this is a better solution because it will give you more data about what happened. Okay, this is how an access log can look like. This is from Tomcat, and this is also customized. This is not the default, and it can tell you what was the HTTP method, what was the URL, the query string, protocol status code, and so on, a ton of details. You can also put like arbitrary headers there, for example, the user agent, if you are curious about that. And this is a output created by, somebody asked how to customize Tomcat access logs. So there are multiple things that you can do. If you are using Spring, then Spring Boot has a property of specifying it. So you can basically just set, I'm not sure what is the name of it. It's not on the top of my head. But if you Google that, then Spring Boot lets you do that. Another thing that you can do is you can define a like on Tomcat, as far as I remember, you can specify it in the Tomcat settings. And also there is a project called Logback Access, which is a access log support for Tomcat. You need to specify or register a Tomcat valve, but in that case, you can specify your access log configuration in the Logback XML. So there are at least 3 ways to do that, depending on your tooling. So this one is Logbook. Logbook is a Java library which can generate you payload logs, and it has like multiple outputs. This is the JSON output, and this thing can give you the raw request and response. So you can see, and not only for your HTTP server or on your server side, but if your service acts as a client, so it has an HTTP client and sends out a request and receives a response, Logbook can record that as well. And in this case, by the way, this is that case. So as you can see, the origin is local, which means this service that emitted this log event, and the type is a request. So the service is sending a request out to another service, to this URL. And that was through, HTTP, I guess, based on the user agent. And this is a response. This is a pair of the previous one. So this was originated from the remote, and this is a response. So somebody is sending me a response back. And this one is really important, this correlation. This is a ID that you can identify the request and the response pairs. So this is how you can find like which requests and responses belong together. And here you can see the whole body This is tricky because logbook can give you certain defaults, but you might want to check these, and you might want to modify these. For example, as far as I remember, if you have a authorization header in your request, logbook will mask it. But as far as I know, it does not mask the cookies by default, which can contain the session ID, which is equally bad, or could be equally bad. This is a example for GC logs. This is just saying that like a young generation was collected. It took like 4.7 milliseconds, and the CPU was sleeping when this happened. This can be very chatty. So also what you can see here is modified. I removed a lot of things from this just to fit onto one screen. Look into this. I believe it is very, very useful in some situation, especially when you want to troubleshoot or like fine-tune your garbage collector. And also there are tools which can read this and visualize what happened under the hood. Okay, let's go back to the first type of logs, the application logs with SLF4J. And I want to talk a little bit about that because Java has a problem. The Java's logging landscape is not really simple. And that's why SLF4J was basically born, because it will give you a facade over the different logging frameworks. And if you want to do some logging with Spring Boot, it will very, very like narrow this down for you. You don't need to deal with this mess. You don't need to choose like which libraries do I want to use. It will pre-configure you like SLF4J and logback, and that will be your by default like logging library. And as I said, SLF4J is like a simple logging facade for Java, and it gives you like a simple API for various logging frameworks. And it also allows you to plug in the desired framework that you want. Logback is one implementation of it. It's a fairly modern one. And Spring Boot will auto-configure that for you. You don't need to do anything to get this. If you go to Start Spring IO, and you will get the simplest Spring Boot application that you can, that will contain these. And you will have logging out of the box. And when I said that you don't need to do anything, I meant that you don't need even write logging configuration. Spring Boot will give you a default one for that as well. You can, of course, override everything, and you can override your logging configuration, or you can override logback, and you can say, I don't want to use logback, I want to use like log4j2. It is basically just the subject of using a different dependency, like excluding one and including a new one. Also, as I mentioned, for payload logs, you can use logbook. It has a Spring Boot starter. It's auto-configured. It works the same way. You just include the jar, and you will get payload logs out of the box. You might need to configure a different logger or like a different appender if you want payload logs in a different file, but out of the box it will be there and it will work. Also, if you want access logs, that's a Tomcat functionality. You can use it via vanilla Spring Boot, or you can also give like logback access or like configure logback access. You need to configure a logback for that, and you can like push your Tomcat access log through logback and use the logback functionalities and the luxury of having logback for your access logs. And the GC logs, they are just like built into the JVM. You can like configure and enable it via JVM arguments. Okay, so that was all about logging. Let's move to the next topic, which is metrics. So metrics is all about having some time series data. And time series data is basically like data points that are changing over time. So if you want to plot it, it's like usually a graph when the x-axis is the time. So it can help you to identify trends, some context. You can use it for anomaly detection, visualization, and also alerting. And there are two big like dimensions or two big properties that distinguish metric backends. Actually, there are one more, but that's not very important here. One of them is how they publish, or how do they receive the data, or how the client needs to publish, because the client can push this data to the backends, or the server can pull this data. And most of the metric backends are the first type, so the client needs to push. But Prometheus, if you have heard about that, that one is polling your services. And also there is another property of metrics backends, which is dimensionality. There are dimensional and hierarchical metric backends, and I think I will tell you what does this mean through this example. So this is one time series. This is a metric that has a name. You can see that's the first line, HTTP server request count, and it has a value, and the value is this last piece, like 2.0. So this means that you received two HTTP requests. And what you can see here in between, those are called tags, and these are key value pairs. And the interesting thing is that dimensional metric systems, they do this. They have key value pairs as tags. Hierarchical systems, though, they don't do this. What they do is that the value of the tag will be in the name of the metric. So in this case, the name of the metric would be, I don't know, HTTP server request count dot tservice dot none dot get, and so on. So it is way harder to know what those values mean. It is way harder to query, and it is way harder to basically like have meaningful data in your hands. So that's why modern metrics backends are dimensional and not hierarchical. If you know JMX, JMX is hierarchical. If you want these different like dimensions in your JMX counter, for example, you need to name them differently. With dimensional systems, it's not the case. And this also brings us to another very interesting feature of metrics, or feature of time series, which is cardinality. So if you have different tag values here, let's say that you have, I don't know, another request, and this other request had an HTTP status code of 500. That means that that one will be another line like this, or like another time series like this. And this property can be a problem, because there is a thing called cardinality, which is a measure of, let's say, the number of elements of a set. So what do you think? What is the cardinality of the outcome tag? So how many different outcomes can you have? Can you guess? There are no good answers, or there are no bad answers. 5, that's very close to what Spring Boot has. It has 6, but I believe like 2 is okay too, like success and failure. So that has like very high or very low cardinality, because it's like just success or failure, or like Spring Boot has like others as well. What do you think? What could be the cardinality of the method, the HTTP method? How many HTTP methods can you have, or can one service have? Can you guess? Like you can say like, I don't know, less than 100 or 7. Yep. I would say like less than 10. Like there are get, post, put, patch, delete, head options, and there are a couple of others. I don't know. It's not a big number. Again, that's the point. For example, if I see the, yep. So for example, if you see the status, the HTTP status, maybe that will be a little bit more, but I would say that less than 100. But how about the URI? So in this case, you can see that this URI is templated. So this name here, it will not change if I query like /t/abc or xyz or 123 or something. All of them will map to this. But what if it's not templated? What if I include the user ID there? That is very, very high cardinality data. And the problem with that is that if you get the Cartesian product of all of these, like let's say that we can have like 5 outcomes and 8 status codes, and I don't know, like another 2 URIs, that's 5 times 8, that's 40 times 2, that's 80. So from the beginning, you can have like 80 different time series. And if you include like some unbounded value of, for example, like a user ID or any user input is potentially high cardinality, your metric system can blow up because it will not be able to handle the amount of data that you are throwing at it. And you don't need to, like, it's not that big of a problem usually. Depends on your traffic, of course, but handle high cardinality data with care. Do not fear it. Sometimes it can ruin your day. And like not including high cardinality data is a very, very good practice. And don't include high cardinality data if you can. But if you have like not too high cardinality, that potentially can be okay depending on your resources of your JVM or the resources of your metric backend. Like high cardinality data will potentially generate a lot of time series. So you need to pay the price of that, of storing those. And with Micrometer, we see this a lot. People are complaining, hey, Micrometer like is causing my JVM out of memory errors. And yeah, it is causing out of memory errors because one of your tags is the user ID. So Micrometer is storing billions of time series for you because you asked it to do that. So be careful. And also anytime when you add a tag to a metric, think about, is this high cardinality or low cardinality? Or if it is high, how high can that be? And if it is too high, then try to normalize it. For example, like this, as you can see, the URI is normalized. It is just like templated so that it cannot grow artificially high. Okay, let's talk about what are the like different things that you can have for Micrometer. I will talk about 3 things here, but there are way more. And I really encourage you to check out the Micrometer's like documentation. This is not necessarily like Micrometer related, but usually metric systems work like this as well as Micrometer. So the easiest thing that you can have is, or the simplest one, is a counter. A counter will tell you how frequent is an event, and it will report you a single metric account. And you can only increment this. So there are no decrementing, and the increment must be positive. This means that all of your counter must be monotonically increasing, or I mean the value of it will be monotonically increasing. For like a good example for this is like a queue. When you insert something, then you can count how many items were inserted or removed. Another very interesting thing around counters, if you like imagine this, that you have a monotonically increasing value, for example, like how many HTTP requests were coming in for the lifetime of this application. If you plot it, then you will get a monotonically increasing slope, which I'm not sure how useful is this. If you can see like, hey, this is the incoming HTTP request count, and you can see the slope. Like, I am not sure if it is telling too much thing to me. But if you plot the rate of this increase, then you can tell more about this. Like you can say that, hey, in this, I don't know, minute, second, or whatever time span, I had like 100 requests coming in. This is basically the first derivative of this slope that you see by time, if that helps. Okay, the second thing I want to talk about is a gauge. And the gauge is basically a current value of something. You can increment and decrement it, but you cannot really, but because it is asynchronous and it is sampled, so you cannot set the value of a gauge directly, but you can set the value of the state object that you monitor with the gauge. So gauge is for monitoring some existing things, and it is, as I said, asynchronous, and also it will only change the value of a gauge when you observe it. So basically this means that gauges are not, they don't care about the intermediate values. They only care about values where you need them. Like, hey, I want to ship my metrics to my metrics backend, or like Prometheus is scraping you that, hey, I need the values now. This is the time when your gauges will be like sampled and the values will be updated. And a good example for this is like with the previous queue example, the size of the queue, the current temperature of the room, of your CPU, or the CPU load that you are experiencing. And this one on the bottom of this slide, this is a very good rule. Never gauge something that you can count, because the counter will give you more data. Because of this rate, you cannot really rate a gauge. Okay, and the last one I wanted to talk about is a timer. And a timer records a short duration of events, and by default it like records or reports the count, the sum, and the max of these events. It can also calculate you percentiles. Like, I don't know, I want to see the top percentile or 90 percentile of something, or 99. It can generate you histograms. It can has SLOs that you can also like see. It is basically just arbitrary values for your histograms, and you can use a timer, for example, to record a latency of a call, or like an outgoing HTTP request, or an incoming, if you will. Also, there are long task timers, which are recording things that are like still in progress. This is needed usually because if you want to record something that takes, I don't know, an hour, then you will get the recording after the end of the hour, which can be bad, because if that task will, I don't know, take 2 hours and you want to set up an alert for that, then you will get an alert that, hey, this task took like more than an hour after like 2 hours. And we have a mantra here, again, never count something that you can time or summarize, because a timer can contain, or it does contain a counter or a count, and it will give you like much more data. And this is the point. I would like to show you a little bit of it's not really a demo, but it's a very interesting, I don't know, property of percentiles. So when people like usually measure percentiles, then usually they have an alert on, I don't know, 90th percentile, like TP90, TP95, TP99, and so on. And this is fine until you have like multiple things that are like communicating or like acting together. And this can cause problems because latency usually does not live in vacuum. And what can happen is that, for example, if you are calculating the 90th percentile, that means that that the chance, that means that the chance of like hitting something that you will like, if you just like hit your service with a request, that the chance of like experiencing something which is higher than the 90th percentile is 0.1 or 10%, which is what the 90th percentile is by definition. So this means that only like 10% of the requests will be worse than the number, I don't know, like 1 second. Let's say 1 second is our 90th percentile. So this will tell you that 10% of the requests are worse than this, 90% is better than this. So this is a good signal, right? And this is like a very, very dangerous thing, I would say, with percentiles. Because if I refresh this page, you can see that there was 33 requests that my browser made. And I am a little bit of 35, I don't know. I'm a little bit sad because of that, because a couple of days ago when Wikipedia showed me like a different site, it was around 80, but we can work with this as well. So the likelihood that you will hit 90th percentile on Wikipedia, or like for this one single request that I made towards Wikipedia, it's 31 requests on the wire, is this. So there is 96% chance that you will hit the 90th percentile, which means that if you have something like this and like you see an environment where services are communicating with each other, then like looking at the 90th percentile might not be the best. Maybe 95 is too low. Like that's 80% of the there is 80% chance that your request will hit this. Let's go 99. That is still like 26. Like quarter of the requests will hit that value. So you can go up on this, or you can just watch max. Because if you watch max, that means that you are already like looking at the highest value. Everything is lower than that. And this is very, very like I would say it happens a lot when people are measuring like time. Okay, so we have Micrometer, which is like a popular metrics library on the JVM for Spring. You can think about SLF4J, but for metrics. It has a simple API. It supports a lot of popular metrics backends, and you can get it with Spring Boot Actuator out of the box. And Spring projects are instrumented using Micrometer, and also like a lot of third-party libraries, they use Micrometer to instrument their code. And when I said SLF4J, but for metrics, these are the matrix backends that Micrometer actually supports, and which is a lot. So you can have a good chunk of coverage here. Okay, let's move to distributed tracing. And as I said, distributed tracing is all about identifying cause. And let's say that we have a user who called this system. This is our topology, and the user got a HTTP 500 error. So how can we know what the user did that led to this error? Or how can we know where is that error coming from? Is it coming from service 1? Is it coming from the database of service 3? Or what happened? What if we have 100 of instances? We can utilize logs that can like partially cover this, but if we will have like a lot of instances, that will be really hard to do. So basically the ultimate question, how can we identify the root cause of this error? And I'm not sure about you, but I have definitely, unfortunately, did this. Have you ever searched for error messages in source code that you saw in the logs just to figure out where is this coming from? It's not a very pleasant thing, I guess. Or let's say that the user see that the system is slow. How can we know what is slow from the user perspective? Or how can we know what is causing it? Is it again like service 1 which is slow, or service 1 is slow because the database of service 3 is slow? And also, can we correlate these events and also the logs so that we can track down what is the cause of a particular issue? Okay, so in order to correlate logs or these events, we at least need a correlation ID. And let's call it a trace ID, because that's what it's called. So when a request comes in, we can attach an ID to that request. In this case, it's like 123. And when the service logs anything that is related to this particular operation, we attach this trace ID to our log events. And the key thing here is that we need to propagate this information to other services as well. So when service 1 calls service 2, the trace ID travels on the wire. And when service 2 logs something related to this operation, the same trace ID will be attached to the logs. And we can do the same for service 3 as well. So if we do this, then as the different services are logging things out, then you can see this ID in the logs. You can find the root cause, and you can basically like gather all of the logs together that belongs to this trace ID. So for example, if you see an error, you can get the trace ID of it and query that, and you will see all of the related log events. But this still leaves a lot of questions open. For example, what if we are tracking the root cause of a slow call? Can we easily like figure out what happened based on the logs? And we need to weigh a track of like every single meaningful operation across our services. That also like a lot of work. But this is what distributed tracing does. It solves this problem for you. So let's say here that conceptually we have a few operations. Let's say service 1 calls service 2. That's one operation. Service 2 calls, it can contain other operations as other services as well. Also service 1 can call like service 3 and so on. So let's call these operations spans, because like a span is a basic unit of work that you want to track. So for example, a network call usually belongs to the span, or an expensive calculation, or any event in your system that takes some time. And if you have a set of spans that you can put into a tree, that is called a trace. So a span is just a basic operation, and the trace is a tree of spans. And if you have a system like this, these two could be spans because like they are network calls to the database. These two could be spans as well, because service 1 is calling service 2. And when service 1 basically will create a span for this call, it doesn't know what will happen in service 2. It will not know that service 2 will like do or create some other spans. Service 1 can also like grab these two operations like C and D, like, hey, I am calling these two services now, I am starting recording this together. And of course, this whole thing is wrapped in one span, and all of them are sharing the same trace ID. So as I said, span is the basic unit of work. It will have its own ID. It will also have the shared trace ID. And also it has a parent ID to track this parent-child like relationship. So with this, basically we know who called who on the network based on these, like the trace ID, the span ID, and also with this parent-child relationship. And also we can see when and where these spans started, stopped, and also what were their duration. And we can attach any arbitrary like metadata to it. By the way, the text here, the cardinality of the text can be high because like it was the tracing systems will not like generate more data if you have a high cardinality tag. Tags are always saved. It's not like metrics. Also, we can have log correlation by writing the trace ID and the span ID into logs. And we can have nice visualization tools to show all of these. For example, this one. This is Zipkin. And as you can see, it's nice, it's colorful. You can have a dependency graph because of this like parent-child relationship. You can also see that the whole thing took like 18.47 milliseconds to process. You can see all of the spans in this like tree-like view, and you can see who called who, when, on what endpoint, also what was the HTTP method, and so on. And the different services are also color-coded, so you can see like which service did what. And also, if you click on one span, you can give even more information. You can see it in the sidebar, like tags and annotations and so on. So if we could have something that automatically instruments our frameworks and our libraries, records all of these spans, lets you instrument your code base, it propagates the tracing information over the wire, and it also adds these details to the logs, we could identify issues across services. And I have good news because that's what Spring Cloud Sleuth is doing. So Spring Cloud Sleuth is distributed tracing support for Spring, and it provides a abstraction layer on top of these tracing libraries. The two supported tracing libraries are Brave and OpenTelemetry. OpenTelemetry right now is in incubator, but I believe I will talk about that later. It will also give you log correlation and context propagation. The Spring projects are instrumented. So if you use a Spring module, then you will see that Spring Cloud Sleuth instrumenting it. Also, there are instrumentation support for other third-party libraries through Brave and Otal that are used under the hood. And it also supports various backends through these libraries. So on one side, we have OpenZipkin, which is like a mature production tested solution where Brave is the tracing library and Zipkin is the backend. And Zipkin basically was the UI I showed you, and it is also a data store. It has multi-language supports and many backend supports the Zipkin format. And we have OpenTelemetry as well, which is a new project. It's CNCF backed. It was based on Open Tracing and Open Census, and it wants to tackle all three pillars like logging, metrics, and tracing. It has multi-language support, and it also has multiple formats. The tracing specification for OpenTelemetry is stable, and the tracing Java instrumentation is still in alpha. The metrics API and the logging, they are not stable yet. And we have Spring Cloud Sleuth Otal, which is the support for OpenTelemetry. And right now it is not recommended in production use because it is still like in incubating. We only have milestone releases because the tracing for OpenTelemetry is not stable yet. Okay, we have a bunch of other like non-conventional stuff, and this is kind of the end before my demo. We can have a bunch of other things like other than logging, metrics, and tracing. And here, basically everything can be the subject of like non-conventional observability that produces an output that will give you some meaningful information about what's inside of your system. In the chat, can you like mention a few or any if you audit tables? Yes. That is one very good example for this. I brought a few here because Spring Boot Actuator will give you a lot of details about your web services. For example, audit events here, that is slightly connected to what Mitch like mentioned as audit tables. It can give you what beans were created, the status of your caches. It can have a health endpoint, an info endpoint, a bunch of things. If you are using Spring Boot, I really recommend looking into Spring Boot Actuator. Check the documentation. It will give you a lot of details about your service. Also, on top of this, you can have a service registry as well, which can give you information about how many service instances do you have, what versions are deployed and what environments, where they are, and so on. This can be very interesting in cloud environments. Also, wait, do we have a question? Yes, I want to talk about that that Rahul just mentioned in the chat. Runtime view of configuration values, and also runtime view about your service. I will give you examples for that. But you know what? Let me give you a quick example right now. So this is an example for the health endpoint. You can get something like this out of the box from Spring Boot. This means that I only specify that I have a database and this is the DB URL. Spring Boot created, or Spring Boot Actuator created this health check for me. And you can see this is our H2DB and it's up and running. It also created a health check for the disk space. And there is a threshold. It's if the disk utilization will be too high, or like I am running out of free space, then this will report down, or the database is down, then this will report down too. And about that, runtime information, this is the info endpoint. And by default, the info endpoint in Spring Boot Actuator, it's empty. But you can use it to provide a lot of data using it. Like you can basically like put any arbitrary objects in it and it will show you in a JSON format. In this case, I can see that my service is deployed in a local environment. That's my environment flag. I was building it with Gradle using these compatibility settings. It was built from this git commit on the main branch, and the commit was made at this time. This is the name of the service. This was the time when I built it. This is the version number. I am creating a version number in this case by just concatenating the commit ID and the timestamp. But if you like want to use like 1.0.1, depending on what you put there, this will show that. This is coming from your build system, by the way. So it's Maven or Gradle. They will generate these properties for you. I am running with the local profile. I have some details about how many memory do I have, or what is the available processor count. These two, by the way, can be very, very interesting in Dockerized environments. Because if you are running in, for example, well, pure Docker, or let's say in Kubernetes, based on your settings, you can get very, very, very wide numbers here. For example, if you start a service in Kubernetes, as far as I remember still, this will be 1 by default. If you are not setting anything, JVM will set this, or not JVM actually, but JVM, Kubernetes, and Docker. As the values will propagate through these, this will be set to 1, which can have very, very interesting consequences. For example, none of your parallel streams will be parallel. All of them will be sequential. You will not get the any parallel GC, only the single-threaded GC will be used, or will be set by default at least. The JIT threads will be sized based on this number, the GC threads as well. So you can get into trouble. This is something that if you are running in Docker or Kubernetes, this is something you might want to take a look at. You can see that I am using Java 17. This is the latest version. It came out recently. It's an Adoptium JDK. What else? G1 was chosen by the JVM. I am in this time zone, or I am not, but the service knows that it is in UTC. The country and the language. You can see that I don't have a M1 Mac. I still have the Intel one. This version of the Mac OS, some network details, when the service was started, uptime, and so on. And Rahul had a question: what is the best way to get a view of properties? I will answer that question in a few minutes. Let me go back here and show a couple of things. Let me do the demo. You can have other non-conventional things as well, as you can see here, but I will demo some of these, so you will see them in action. Let me stop sharing and share another screen. If Zoom is nice to me, but it's not really. Okay, now, can you see my screen?
Yep.
You should.
Yes.
Okay, cool. Let me bring a list of things I want to show. So first of all, let me generate some traffic. I am calling to call a service. We don't know anything about this. I'm just calling it. It is for making tea. So I want to make some sencha, a small amount of it, and here is the recipe, and I am calling it a couple of times. Let me generate a few errors. If Chrome lets me doing that, yeah. So I have some data, success and errors. So let me show you what I can, or I see in the logs. And first, let me show you the service log. And as you can see, this is the default log4j, logback, whatever logs. Usually you can see something like that, but there is something interesting here. This one. What you can see here, this is the name of the service, and this is the trace ID, and this is the span ID. So if I search for this trace ID throughout the logs, I only have these 4 that you can see here. I can see which log entries belong together, which is a really nice thing to have. And this is called like log correlation. And what I am doing here is I am just logging out like the outgoing HTTP requests. So these 4, you can see that when I called that service, then these things happened. Or actually, this is half check. So let me try to find the ones I did. Yes, here. So these 4, they belong together. So I can see that for this one particular request, there were an outgoing call to this endpoint and another outgoing call to this endpoint. Or if I want to check, like if an error happened, I should be able to grab that as well, like the IDs of a stack trace. Okay, let's look at the metrics. So I set up Prometheus here, and the interesting thing in Prometheus that because it is polling your services, you can see all of the services here that Prometheus is monitoring, and you can see these meters, and you can graph them, and you can like do a bunch of things with them. But usually Prometheus is used as a backend, and it is not used as a graphing, dashboarding, alerting system. Usually Grafana that is used for that. And if you set up Grafana with Prometheus, then there is a thing called Grafana Hub, which contains a bunch of different like dashboards, let's say that, which are pre-built for you. And if you don't really need to do too much with these, you just need to say, hey, Grafana, I want to use this dashboard that was pre-built for this system from Grafana Hub, and Grafana will import for you. And that's how I have these here. So this JVM, Micrometer, Spring Boot 2.1 stuff, I'm using, by the way, 2.5. So this is just the name of the dashboard. Somebody named it there on Grafana Hub. This can give you a lot of information about what happened in your system. For example, this bump here, this might be me who like called the service. And if I go back here, there were a couple of errors as well. It is showing 0 because I only like hit it, I don't know, like twice. So when it's like averaged out, it's like still like 0 point something, 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 and Grafana shows it as 0. So it wasn't a lot of errors I sent in. But by default, out of the box, you can get a lot of details if Grafana will be nice enough and load all of these. Yes. So I really encourage you to take a look at these, and I go to Grafana Hub, search for, I don't know, Spring Boot, Prometheus, and you will find these things. This is another one. It shows you almost the same thing, I guess. There is a lot of details there, and you can also like copy paste them together. So you can edit these. It's persisted onto disk as like a JSON. So you can like mix and match. You can create your own if you want. This is for the JDBC connection pool. And if I choose a service which has like some database connectivity, then it can show me a couple of things. Here it is like not really visible because the pool doesn't like resize, and I'm not having any like pending connections or active ones. So, but if I would have traffic, this would show that easily. Okay, and the last thing from the 3 pillars is Zipkin. So this is the distributed tracing backend I showed you And if I run this query, then you can see all of these requests I made before. And you can see that some of them are like this bluish color, and some of them is like more reddish. The red ones are the failed ones, and these blue ones are successful ones. So if I click on one of these, I can tell a lot of details about what happened. First, this is the trace ID, and this trace ID I can use to go to the logs so that I can see what log entries belong together if I want to. Also, you can see that there was this T service, which I called, which called voter service and tleaf service, and the call wasn't in parallel, it was sequential because this happened first, and that happened on the timeline, and this voter service called the voter database, and the tleaf service called the tleaf database. Okay, also, if I click on these, I can see another bunch of details. For example, what was the HTTP path? What was the HTTP method? What class was called when I made this call? And also what method was called in that controller class. Also, if I click on the span of the database, I will see the raw select query if I want to. I need to enable this, but this is the select query that the service sent to the database. And this is quite ugly because I am using Hibernate. So, but if you write this by hand, you can see whatever beautiful select query you can came up with here. Okay, so these were the three pillars. And as I said, like Spring gives this to you almost out of the box, because logging, that's completely out of the box. Metrics, either you put Micrometer on the class path, or you are using Spring Boot actuator, and you can get what I showed you here. Of course, you need to run Prometheus and Grafana, but that's the idea. If you have a backend, then Spring Boot will provide you the metrics. And for distributed tracing, what you can see here, if you have a running Zipkin instance, then you just need to put Spring Cloud Sleuth on the class path, and you can get something like this. So you can get very, very far in very, very little time with these by just putting dependencies onto your class path. Okay, let's go back to Rahul's question about like runtime view of configuration values across applications. Let me show you this guy. This is called Spring Boot Admin. And what it does, it is basically showing me all of my running services, because I am registering all of my services into Eureka. Eureka is a service registry. And I am registering my services into here, which, by the way, like Spring Cloud does this for you out of the box if you bring in the right dependencies. And I am just pointing the Spring Boot admin to Eureka. So right now, I know like all of the instances of all of my services that I can have. And this, by default, like it is in this like board, it is showing me like what services do I have. And also this is the version number. It's weird because I did it in a weird way, commit ID timestamp, but it can be 1.0 as well. If I click on it, it will always also show me the environment. Like this is running in a local environment. And if I go further and click on the service, these are the details that Spring Boot admin can get from Spring Boot actuator. And wait a second, because we have a question. Okay, so this is everything I showed you is auto-configured in Spring Boot. So you can make some of these work with vanilla Spring. For example, Micrometer, you can add it as a dependency, and you need to configure it on your own. Spring Boot is basically adding the auto configuration for this for you. Is there any connection? What I've heard branded as Spring Cloud. I'm not 100% sure I understand that question. The connection here is Spring Cloud Sloop, which is the distributed tracing solution that is branded as a Spring Cloud project. Micrometer is not branded as a Spring project. It is just a metrics library, which is, by the way, like maintained by the Spring team, but it's not strictly a Spring project. Though Spring Boot is using it, and it is auto-configuring it for you. And it auto-configures like logback as well, and so on, and a lot of other things. So where was I quickly? So this is Spring Boot admin's like detailed view. And what you can see on this, like, I don't know, first screen or the detail screen is basically the same thing I showed you before. This is the health endpoint and the info endpoint. And like there are some like very basic metrics that you can see here about what was the uptime, what PID I'm using, threads, some memory details. This is not a replacement for a metric system or a metric backend. This is just some kind of like, hey, is there something like terribly wrong? You can basically see it here. Also, another actuator endpoint can give you the metrics. I am not going through to this. You can basically like select these and like see these. And I believe this should answer the question of Rahul. So this will show you all of the like runtime values of your properties. So for example, if I have a URL of a service, for example, this one, I can see the value here. Or if I have, I don't know, like a timeout, I can see those as well. I can search them, everything is here. If Spring Boot will detect that this property could be a secret, it will mask it. So that is based on the name of the property. If you name your properties right, then Spring will mask those. So you will not see the secrets here, thankfully. But you can see a lot of other details. By the way, you can, like if you have Spring security on the class path, then you can authenticate this endpoint. Also, you can put this endpoint to another port that you don't let out on your firewall. So you can secure this because from this, like this level of observability can be also a little bit dangerous. Like if I know what libraries are you using and what versions, I can just target you and check, hey, is there any 0-day, is there any 0-day vulnerability for this jar, and so on. This one is a little bit of connected. This the beans endpoint will not show you the properties. This will show you the beans that Spring creates for you. And there are others as well, like there are configuration properties. This is like a unique thing in Spring. If I would have any scheduled jobs, I should see that here. I can read the log file. Like I don't need to like find the logs of this one particular service. I can read it here, and also I can download if I want. I can set the levels of these loggers. So if I put them into, oops, let me go back to debug. I should see debug level messages now. Yes, I have a bunch of those. Or maybe this, why it is not following it? This must be old. Oh yeah, now you can see that it is not stopping logging. Like it has a bunch of debug messages. So let me put that back to info. This is some information about your context or the Spring context startup. This will show you which or what steps did Spring made, and also like what was their duration. You can get some JVM information, for example, like any JMX counter. You can see those here, and you can browse them. You can get a thread dump, you can get a heap dump, and that's why you must, if you are doing this, by default, it's like not available. You need to turn these on, but you need to secure these if you are doing this. You can see all of the mappings, like the Spring MVC mappings, what endpoints do you have? And if you have caches, you can see that as well. And also let me show you another thing, but for that I need a service which uses a database. So if you have Flyway is a database migration library or tool, then you can see the database migrations and the version of your migration script as well. So as your database is evolving, as you are making changes on it, you can see those changes here, and you can see if like a database is behind of a service or not. Also, it has a nice wallboard, and it will be red if one service is down. You can put in this onto a screen, and it can show you like if something is bad. Also, and I forgot to show this to you, if I go back this here to Zipkin, because I have this like call tree, like which component is calling what component, I can see a dependency view. So this is the topology of my like components. I have a T service, I have a voter service and a TLeaf service, and this service is calling those. And voter service is connected to the voter DB, and TLeaf service is connected to the TLeaf DB. And that's all I had. You don't need to create like architecture diagrams. You can just come here, and this can show you. Also, it will be, if this one, what you can see here, it tries to show you the real traffic, and every once in a while you can see like a red one. The red one was when I tried to simulate the error or the exception, and it is simulating this between these timestamps. Okay, there are two more things I want to show you, and that will be the end of this talk. One of them is Swagger. So Swagger is a API specification library plus UI. So if I add Swagger to my Spring Boot application, I can browse here all of those operations that this application provides. So for example, in this case, I can see that I have a get/t/some name endpoint. And if I come here, I can like fill these out. Here, Swagger gives you options to like give examples, give like more details. I did not do it, or give like default values. I can say Sencha and give me a small one. And if I execute this, this is my response. And also I got a cur command. So if I have like some like issues with that, I can just send it to somebody else that, hey, this is, by the way, how you can like reproduce this. Okay, so the last thing I wanted to mention is connected to API discoverability as well, because Swagger like gives you a nice idea of how your APIs look like. And if I go to Postman and hit this TLeafs service, then you will see something interesting in the response. Can I make this bigger? Can you read this? Or should I try to make this a little bit bigger? I can zoom in a little bit. Okay, so what you can see here is that this is an array, and I have 1, 2, and 3 elements of this array. And also, there is a section here that tries to indicate that this API is paginated. I have total elements of 3, total pages of 1, because the page size is 20, so everything fits into 1 page. But if I hit this link, which would be this link to the same endpoint I hit, but it's a little bit more verbose because the default parameters are filled. If I hit this and say the size of the page should be 1, then I should get 3 pages. So first, the first page contains only one resource, which is this one. It's the essential. And I can get links to the other ones. I can see what was the first element or the first resource in this collection. This is itself. I can see what is the next one and what is the last one. There is no previous one because I am on the first one. So if I go next and hit this one, then now I should see that there is a first one, there is a last one, there is itself, a previous one, and the next one. This is called HATOS, hypertext as the engine of the application state. And what it does, you can add links, hyperlinks to your resources so that they can reference each other, or they can reference some relations. So for example, if this would not be tea leaves, but it would be, I don't know, books, then I could attach a link to this. Hey, show me the author, the whole resource of the author of this book, which makes a lot of sense in terms of API discoverability. And if you want to make your APIs more observable. And I believe that's all I had for today. Do you have any questions? I do. Okay, let me stop sharing and let me check the chat.
Yeah, that was really informative, Jonathan. That was definitely interesting. I ran observability a couple of different projects over the last couple of years, and in a way, it's interesting to see how things have evolved, and at the same time, they're still kind of the same, I guess. Just out of curiosity, what stacks do people use? I mean, you obviously mentioned Prometheus and Grafana, right? And that was one of the stacks that we used at a company that was a startup at one point in time, and then went public and became a much larger company. So then they were transitioning over to Datadog, which was challenging, frankly. And I think they still have both systems that they run, unfortunately. So I'm just curious, what other stacks? I've had some experience with a tick stack in the past, couple of years ago, but I'm just curious from people if they want to maybe just type in the chat window, or Jonathan, if you want to talk about what stacks, places that you worked at have used.
I can give you some data points because I also have access to the how popular are these registries for Micrometer. Micrometer calls those modules that supports a particular backend the registry. So we have a registry for Prometheus, we have a registry for Influx, and so on. And the most popular registries are not in this particular order, but the top 3 or 5 are Prometheus, Influx, StatsD. Unfortunately, per my opinion, StatsD is a very, very old library, but I believe these are the top 3. I'm not sure I will be able to give you a top 5 though. But these, I believe, the registries that are the most frequently used are the open source ones. Yeah. That you can basically the the solutions that you need to pay for, those are like less popular because like people are like need to invest to those. But those solutions are usually using like some of these in their backends. Not always, but or support these protocols. For example, like the StatC protocol is supported by a lot of these solutions.
Yep. That's what we use with Datadog actually, is StatC for the custom metrics. Yeah, no, that actually that aligns with my experience also. So totally makes sense.
Okay, Rahul had another question about what is the relation, if any, with Micrometer and Spring Actuator. So Micrometer is a metrics library, and it's not a strictly Spring project, but it is maintained mostly by the Spring team. And Spring Boot Actuator is trying to give you like production-ready features. And because of this, if you bring in Spring Boot Actuator, it will bring in Micrometer for you. So if you are using Spring Boot Actuator, you will get Micrometer for free, but you can use Micrometer on its own if you want. And there was another question. Oh, what are some other resources to look at to learn more? I would highly encourage you to take a look into the documentation of Micrometer, the documentation of Spring Boot Actuator, and the documentation of Spring Cloud Sleuth. You will find a lot of details and the information there. Oh, the code from the demo. Yes, that is. Let me put into the chat, and if you can find me on like Twitter or on GitHub. This one is on GitHub. It's an open source repo. It is called T-Service. Or sorry, T-House. That's the name of it. Let me put this into the chat.
You can put it on Meetup also if you want.
Yep, I will. So this was basically the app I demoed. Prometheus, Grafana, Zipkin. There is a Docker file, sorry, Docker Compose file. So you can just start all of these with one single command, Docker Compose up. And you can start all the 5 services that you saw with Gradle boot run. But I believe it is in the README. If it is not, I will put it into there. And oh yeah, it is there. So if you open the README, Gradle boot run, that will like start all of the services, and Docker Compose up if you have Docker Compose, which I believe now it's built into Docker. So you should be able to start everything and show or see the same thing I just demoed today.
Cool. One more question.
Yeah, if Sleuth does not send trace info to Zipkin, where can I get the debug info/log? So if you add Spring Cloud Sleuth into or onto your like a class path, it will not send the spans, the tracing information to Zipkin out of the box. You need to ask Spring Cloud Sleuth to use like Zipkin as well, which is just another dependency. I believe it is called Spring Cloud Sleuth Zipkin that you can just like bring in, and from that Spring Cloud Sleuth will send the spans to Zipkin. If you don't want to do it, these details, that the trace ID and the span ID, those will be in your logs anyways. So if you're just using Spring Cloud Sleuth, you will get log correlation. If you are also bringing in Spring Cloud Sleuth Zipkin, then you will get log correlation, plus your spans will be sent to Zipkin. Let me know if this answers your question. How reactive Spring metrics are handled? Do we need to add anything extra config? It's way more tricky because reactive, it's tricky, but you don't need to do anything else. So you just get like Spring Webflux or the Spring Boot starter of Webflux, and also Spring Boot actuator, and you will get the same metrics as with Spring MVC. So Micrometer will be configured, and the Micrometer will be used in order to instrument Webflux.
All right, great. Any other final questions here? Otherwise, yeah, I'm sure you can probably catch Jonathan on GitHub or any of the open source projects that he works on for any follow-up questions.
Oh yeah, you can send a message to me on Twitter, or just like mention me, or you can also mention, I don't know, like Micrometer or Spring Cloud, and somebody will answer. Or if you have a question like on Stack Overflow, just use the tags like Micrometer or Spring Cloud Sleuth, and we are watching those.
Cool, awesome. Well, thank you, Jonathan. Appreciate it. If you want to stop the recording, I think we'll wrap up.
Stop it.
And make sure you stop it, because I think if you don't stop it, it runs into problems.